This is Sarah Wilkinson from Humber College and the University of Guelph-Humber. In this video, I'm going to continue talking about action potentials, and I'm going to specifically talk about what a threshold is. I would encourage you to make sure you watch the video on action potentials before watching this one. In that previous video, I covered how resting membrane potential is negative, and that when a stimulus occurs, there's a rapid depolarization followed by repolarization. Now, I wasn't entirely truthful in that video. Sometimes a stimulus occurs and there's not a depolarization. In this video, I'm going to talk about the concept of threshold. In the previous video, I discussed how the resting membrane potential is negative. There's more negative charges inside the cell than outside. And that a stimulus will cause sodium channels to open up. Therefore, sodium can move down its electrochemical gradient, rendering the inside of the neuron more positive. If a few sodium channels open up, the inside of the neuron becomes a little bit more positive. What the threshold is a value, usually around minus 55 millivolts, that will automatically cause an action potential to happen. Only if the membrane potential value reaches a certain threshold will depolarization occur. If enough sodium channels open up, the inside of the cell becomes slightly less negative, or we can also say more positive, an action potential will occur. This doesn't always happen. Sometimes only a few sodium channels open up. So if the membrane potential does not reach threshold, not enough sodium channels open up, no depolarization will occur. And the action of sodium and potassium pumps will return the value, the resting membrane potential, back down to minus 70. So here we call this a graded potential. There was a slight increase in membrane potential, but not enough to reach threshold, so no action potential occurred. Sometimes a stimuli causes hyperpolarization. This stimuli would open potassium channels only. This way, potassium will leave the neuron, rendering the inside more negative. And this will make reaching threshold even harder. So if any sodium channels open up, we're going to see that we return back to resting, and it's going to make it even harder to reach that threshold. In following videos, I'm going to talk about excitatory versus inhibitory neurotransmitters. And sometimes the excitatory ones open sodium channels, while the inhibitory ones open potassium channels. So I'd encourage you to watch the video that I'm going to do on the synapse, and we'll go into this further.